Network representation. The network model in this activity incorporates many of the technologies that you will master in your CCNA studies. It represents a simplified version of how a small to medium-sized business network might look. Feel free to explore the network on your own. Identify common components of a network as represented in Packet Tracer. The icon toolbar at the bottom left-hand corner has various categories of networking components. Down here, you should see categories that correspond to intermediary devices, end devices, and media. Intermediary devices like network devices, end devices, and media, they are the connections. The connections category with the lightning bolt icon represents the networking media supported by Packet Tracer. These are the connections. Click here and okay, these are the connections: console, straight through, crossover, fiber, phone, coaxial, serial DC, serial DT, octal, IoT, custom cable, and USB cable. There is also an end devices category and two categories specific to Packet Tracer: custom-made devices and multi-user connection. This is the category of end devices, all end devices, and this is the click here category for multi-user connection. And custom-made devices like this category of components list the intermediary device categories. Okay, go to network devices. These are the intermediary device category and list first routers, switches, hubs, wireless devices, security devices, and WAN devices, or WAN emulation. Without entering into the Internet Cloud or Intranet Cloud, how many icons in the topology represent endpoint devices? Only one connection leading to them. Okay. Remember, end devices are PCs, servers, printers, IP phones, smartphones, laptops, tablets, and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Maybe they are 17 counting the IP phones, but in this case they are only 15 because the question says only one connection leading to them. Count the IP phone and PC like only one connection. So that's why they are 50. Otherwise, they are 17. Without counting the two clouds, how many icons in the topology represents intermediary devices? Multiple connections leading to them. Intermediary devices are routers, switches, layer 2 switches, layer 3 switches, wireless access point, and other devices like firewalls. Okay, count 1, 2, 3, 4, 5, 6, 7, the wireless access point, 8, this switch S4, 9, this router, 10, this modem, and 11, this wireless router. So the answer is 11. How many end devices are not desktop computers? This is very easy. 1, the server. 2, the laptop. 3, smartphone. 4, the printer. 5, another server. 6, tablet. 7, another laptop. And 8, another printer. Answer is 8. How many different types of media connections are used in this network topology? Okay, go to connections and look at this. This is the copper straight through cable. It's one here. Now this red cable is serial cable. 2. These are the wireless connections. 3. And this blue cable is the coaxial cable. 4. The answer is 4. Explain the purpose of the end devices. In packet tracer, only the server device can act as a server. Desktop or laptop PCs cannot act as a server. Based on your studies, so far explain the client-server model. In modern networks, a host can act as a client, a server, or both. Software installed on the host determines the role it plays on the network. Servers are hosts that have software installed that enables them to provide information and services, like email or web page, to other hosts on the network. Clients are hosts that have software installed that enables them to request and display the information obtained from the server. A client could also be configured as a server simply by installing server software. List at least 2 functions of intermediary devices. Regenerate and retransmit data signals. Maintain information about what pathways exist through the network and inter-network. Notify other devices of errors and communication failures. Direct data along alternate pathways when there is a link failure. Classify and direct messages according the quality of service priorities. Permit or deny the flow of data based on security settings. List at least 2 criteria for choosing a network media type. The distance the media can successfully carry a signal, the environment in which the media is to be installed, the amount of data and the speed at which it must be transmitted, the cost of the media and installation. Compare the contrast, Lans and Wans. Explain the difference between Lan and Wan. Give examples of each. For example, this square is a Lan. This central environment is a LAN, local area network. Also, this branch square is another LAN. And this home office is a LAN. But one wide area network is this part, the connections to internet, connections to intranet, and other types of connections that covers wide areas. LANs provide access to end users in a small geographical area. A home office or a school campus are examples of LANs. WANs provide access to users in a wide geographical area over long distances spanning a few miles to thousands of miles. A metropolitan area network and the internet are examples of WANs. A company's intranet may also connect multiple remote sites using a WAN. In the Packet Tracer network, how many WANs do you see? Okay, 1 internet and 2 intranet. How many LANs do you see? Okay, 1, 2, and 3. The internet in this Packet Tracer network is overly simplified and does not represent the structure and form of the real internet. Briefly describe the internet. The internet is mostly used when we need to communicate with a resource on another network. The internet is a global mesh of interconnected networks, internetworks. What are some of the common ways a home user connects to the internet? Cable, DSL, dial-up, cellular, and satellite. What are some common methods that business use to connect to internet in your area? Dedicated lease line, Metro, Ethernet, DSL, cable, satellite. Add an end device to the topology and connect it to one of the LANs with a media connection. Go to end devices. For example, choose a PC. Place the PC here and use a connection, a copper straight through cable. Then connect this PC using the fast Ethernet port on PC to connect a switch on any port on the switch. For example, fast Ethernet 1. What else does this device need to send data to other end users? Yes, this PC needs an IP configuration. Can you provide the information? Yes, I can provide that information with verifying another device. For example, go to PC4 and verify the IP address. The IP address is 10.3303. Subnet mask is this, default gateway this, and DNS server this. And this PC are using DHCP. So this IP address information is automatically assigned by a DHCP server. Also, you can configure this with a static configuration using these parameters. And go to your new PC, PC0, recently added, and go to desktop and use the DHCP to obtain DHCP configuration and DHCP request successful, so you can get the IP information. Is there a way to verify that you correctly connected the device? Yes, for example, on PC0, recently connected and close the IP configuration and go to command prompt. Verify with ipconfig command. Verify your IP address and default gateway. For example, ping your default gateway to verify that this device is correctly connected. Success! Add a new intermediary device to one of the networks and connect it to one of the Lans or Wans with media connection. For example, go to Network Devices and select Switches and add a new switch. For example, a 2960 switch and place it here. Go to Connections and select a copper straight through cable to connect a port on this switch and connect to S4, any other port on this switch. What else does this device need to serve as an intermediary to other devices in the network? Okay, this device needs end devices. Go to end devices and select a PC, place it here, and use on connections, use a straight through cable to connect the fast Ethernet port on the PC to any other port on the switch. Open a new instance of Pocket Tracer and create a new network with at least 2 LANs connected by a WAN. Connect all the devices. Okay, you can do it here. It's not necessary a new instance, and I can create my another network. Okay, 2 LANs connected by a WAN. Okay, for example, create the first LAN, use a 4321 router, another 4321 router, and another 4321 router. This, for example, will be Internet ISP. Okay, this is the Internet service provider. Router 0 for LAN 0 and router 1 for LAN 1. I will choose switches. On switches category, 2960 switch, another 2960 switch, and devices like PCs, connections, use copper straight through cables to connect PCs to switches. Now connect switches to routers, switches, and finally connect the routers using gigabit interfaces. Now, use this rectangle and select the rectangle. This is LAN 0 and this is LAN 1. And use this lab nodes LAN 0 and 1, and this is 1. Click here and point there. Now you have two LANs connected via WAN. Connect all the devices, investigate the original packet tracer activity to see what else you might need to do make your new network functional. Record your thoughts and save your packet tracer file. You may want to revisit your network later after you have mastered a few more skills. First of all, you need IP configurations here. The addressing on this network. Once addressing is configured, you need to configure a routing protocol. Then you will get connectivity from this PC6 to this another PC, PC7. Thank you very much.